Okay, for question number 32, and this question has two parts, A and B. So, why is an alternating current considered to be advantageous over direct current? So, alternating current is the one, as a name suggests, alternating. It keeps on changing its direction uh, with the passage of time, or we can say during the fixed intervals. And direct current is the one which does not change its direction. The direction remains, it's a unidirectional current. So, so alternating current is advantageous for the long distance transmission of electric power. Why? Because the alternating current are, so that means the current has to be changed into the alternating current so that it can be transmitted over long distances. And because by changing the current, the alternating current, it can be we can reduce the loss of electric energy in the form of heat and in the form of sound energy. So we can say that alternating current can be transmitted over long distances without much loss of electric energy. So we can say that why alternating current is used. So alternating current is, so that means the electrical supply that comes to our home is the alternating current. So if we use the alternating current over long distances, it's economical. It reduces loss of electrical energy in the form of heat. So that's why it's considered, the alternating current is considered to be transmitted over long distances. It reduces loss of electrical energy, you can say, in the form of heat. Because we know that whenever current travels over wire, in the wire, heat energy is produced because of the heating effect of electric current, but because we have to reduce that, so alternating current is the best option to transmit it over long distance. It reduces loss of electric energy in the form of heat. Okay, now this was the first one. For the second one, how is the type of current used in household supply different from the one given by the battery of dry cells? So household supply is AC and battery of dry cell is DC. So we can say that here household supply is alternating current. So that's the difference. It's the alternating current, and a battery of dry cell, it's the direct current. That's the difference, which is called DC. And DC is a current which is unidirectional, direction does not change, and in alternating current, direction changes. So this is, if you want to draw the graph for the alternating current, this is how it goes. And for the direct currents, it's unidirectional with the passage of time. It does not change its direction, it's constant. So this is DC and this is AC current. Okay. Now, how does an electric fuse prevent the electric circuit and appliances from the possible damage due to short circuiting or overloading? So electric fuse is a safety device and it has a low melting point wire. So when there is excessive current due to short circuiting or overloading, the wire gets heated and it melts, thus breaking the circuit. So we can say that it, for the fuse, it melts and breaks down the circuits. When there is current of higher value than its rating. So if fuse is of 5 ampere and if current exceeds the rating of it, that is above 5 ampere, the fuse wire melts and breaks down the circuit. So it melts and breaks the circuit when a current of excessive value or higher value than its rating, because we have the ratings for the fuse. going to it. That's how the fuse works. So it melts, breaks the circuit, and has no excessive current flows then. Okay, for next question, B, for the current carrying solenoid as shown in the figure, we have to draw magnetic field lines and give reason to explain that out of the 3 points A, B, and C, at which point the field strength is maximum and at which point it's minimum. Okay, so this is the OR part, and we know that the solenoid is a closely wound insulated copper wire in the form of a cylinder. So this gives us the shape of the cylinder, closely wound insulated copper wire with a number of turns. So this is a solenoid, and if the current is given to it, this is now a current carrying solenoid. Now, when the current is passing through it, magnetic field lines inside the solenoid are parallel set of arrows, and they emerge from one end, which is called the north, which becomes the north pole, and merge at the other end, which becomes the south pole. So this is how the magnetic field lines goes. So parallel in the middle and form closed loops. So they emerge at one pole and merge at the other end. So where they emerge, so at this point the magnetic field lines are coming out. So the magnetic field lines are coming out from here. So this is emerging point, which is called dot, and this is the merging point. The magnetic field lines, they merge here. They goes into the solenoid. So this is where it merge and it becomes south pole. So it behaves like a bar magnet. Now it's given that we have 3 points. One is in the middle. So we have 3 points. One is in the middle, which is point A. So let's say this is point A and the other one is outside here. Let's say this is point B and the other one is at the pole, which is point C. So where is the magnetic field lines? The strength of the magnetic field line, we have to compare it at A, B, and C. So maximum strength, what is given in the question is at give reason to explain that out of 3 points A, B, and C, at which point the field strength is maximum, at which point it is minimum. So maximum and minimum, we have to identify these points where it's maximum and where it's minimum, and we have to give the reason. So maximum is at point A. So at point A, because the magnetic field lines are crowded. So point A here is this point. So it's maximum at point A because here the field lines are crowded. So we can say, and minimum is at point B because the magnetic field lines are, because if we draw more magnetic field lines, here the magnetic field lines are, they have distance between them. They are away from each other. So this is the minimum and this is the maximum. The A point is the maximum because here the magnetic field lines are crowded. So maximum is at point A and reason because the magnetic field lines are crowded and the degree of closeness gives the strength of the magnetic field because magnetic field lines are crowded. Okay, now it's maximum at point A and minimum at point B because maximum at point A and minimum at point B because magnetic field lines, they are away from each other. They have some distance between them. So magnetic field lines, we can say they are far apart. Because if we draw some more magnetic field lines here, so if we draw a magnetic field line at this point, so these magnetic field lines are, sorry, these magnetic field lines will have some distance, so they are far away from each other. Here at point P, we will have one more magnetic field line which will be far away from each other. So here the magnetic field strength is minimum. It's maximum here because the field lines are will be crowded here, and C is a point just away from the pole. So this is away from the pole. So this there will be some magnetic field line, magnetic field strength here, but the maximum would be here because the magnetic field lines are more crowded here. And this is the direction of the current given to the solenoid, because these are the terms of the solenoid. Okay, so maximum is at point A and minimum is at point B. Now next is at which point it is maximum and minimum. Okay, so we are done with part B. Let's move on to the next question.